All right, let's look at question C. And so here we've been given angle B is 65 degrees. So I'm going to solve for angle A because I know angle A plus angle B has to equal 90. We know angle B is 65 degrees. So if we subtract 65 from both sides, we get angle A has to be 90 minus 65, which gives us 25, I think. Is that right? Yes, 25 degrees. Okay, so now we know all of our angles. Let's look at little b now. So relative to my known angle of 65 degrees, little b would be my opposite. And the side I know, C, is my hypotenuse. So I'm going to use the sine rule then, or the sine ratio, because I know my hypotenuse and I want to know my opposite side. So sine of any angle theta is opposite over hypotenuse. So sine of our angle 65 degrees is little b over 16. And so let's multiply both sides by 16. And we get little b is 16 times sine 65. And so to the nearest tenth, I get 14.5. And the last one we need to do is little a. So relative to angle B, I'm going to use angle B again. I know my hypotenuse. Now I'm looking for my adjacent side. So I'm going to use the cosine ratio. So we know cosine of any angle theta is adjacent over hypotenuse. And by the way, there's other ways I could have done this. I could have used the tan ratio and used that 14.5 for B that I just solved for. But again, I tend to try to avoid the ones that I solved just in case I made a mistake. So here, cos of 65 degrees is little a over 16. And so we can multiply both sides by 16. And so I get little a is 16 times cos 65. And to one decimal place, that gives me 6.8. And now we've solved all of our angles and all of our sides, so we're done. Okay, let's look at the next one. So here we've been given two side lengths. We need two angles. Let's start by finding little c, because I know I can find little c with Pythagorean theorem. So a squared plus b squared equals c squared. So 35 squared plus 40 squared equals c squared. And so let's calculate that out. I get 2,825. And so now I want to square root both sides, because if I square root c squared, I end up with just a plain c, which is what I want. So I get c is, and this should be out to one decimal place, so 53.2. Okay, now let's work on our angles. So let's look at angle A. Okay, and the last one we just did, we were solving for little c. Okay, so angle A, relative to angle A, if it's my target angle, then I'm looking for my hypotenuse. No, I'm not. I already found my hypotenuse. I'm looking for angle A. I'm looking for angle A. So what are two things I know? Well, I know my opposite side, and I know my adjacent side. So let's use the tan ratio. So we know tan of any angle theta is opposite over adjacent. So tan of angle A then is going to be 35 over 40. So let's convert that to a decimal. And I get 0.875. So let's take the tan inverse of both sides. So we want to take the tan inverse of our decimal ratio because that will give us our angle. And what do we get? To the nearest degree, I get 41 degrees. And last but not least, I need angle B. And so angle B, there we go. Angle B, we can calculate because we know angle A and angle B together have to add to 90 degrees. We found angle A was 41 degrees. So if we subtract 41 from both sides, we get angle B is 90 minus 41. And that'll give us 49 degrees. And now we have solved angle A, angle B, and little c, so we've solved everything. Okay, let's take a look at the next one. So where to start here? Well, I think I'll start with something SOHCAHTOA. Actually, let's start with angle A. I know angle A plus 42 degrees has to equal 90. So we can subtract 42 from both sides. And we get angle A is 90 minus 42, which gives us 48 degrees. Okay, now let's look at our side lengths. So relative to that 42 degrees, little b is my opposite side. C is my hypotenuse. A is the adjacent. So I want to use the adjacent. Let's solve for little b. So I'm looking for opposite and I know my adjacent. So let's use the tan ratio then. So tan of 42, well, I should start with the general statement. Tan of theta is opposite over adjacent. So tan of 42 degrees is little b over 60. Let's multiply 60 on both sides. And we get little b is 60 times tan 42, which to one decimal place gives us 54.0. Okay, now last one, we could use Pythagoras to solve for little c, or we could use cosine. Let's use Pythagoras. If you're going to do Pythagoras, I recommend though using the whole, like more decimal places for this number here, because 54.0 was an approximation. Let's make it a little bit more precise. So I'm going to make it 54.02424, or you can save the number on your calculator if you know how to do that. Okay, so we're looking for little c. I know a squared plus b squared equals c squared. A is 60, so 60 squared plus 54.02424 squared. Using lots of decimal places like this will just prevent rounding error. So when we calculate that out, I'm going to use the entire number stored in my calculator. If you just use what's written there, you should get something very, very, very close. And so I get 6,518.6187, blah, blah, blah. I'll just round it to 619. And then we're going to square root both sides. And again, I'm just going to keep that stored in my calculator so I have the entire number. And square root that whole number. And to one decimal place, that gives me 80.7. And so if this were a test, I might try doing the cosine ratio and just make sure I get the same answer. And that'll help confirm that you've done everything correctly. Okay, next one. We want to solve this triangle here. Let's start with angle B. So we know angle B plus angle A have to add to 90 degrees since this is a right triangle. And A is 23 degrees. So we can subtract 23 from both sides. And we get angle B is 90 minus 23, which gives us 67 degrees. All right. Now let's use some SOHCAHTOA to find our side lengths. So relative to my known angle of 23 degrees, little a is my opposite side, little b is my adjacent, and little c is my hypotenuse. So let's start by figuring out our hypotenuse. So we know our adjacent. We want to figure out our hypotenuse, so I'm going to use cosine. So cosine is adjacent over hypotenuse. So cosine of 23 degrees is 7.6 over little c. Let's multiply both sides by little c. And so we get c times cos 23 equals 7.6. And now to isolate the c on its own, we're going to divide both sides by cos 23. Okay, now that leaves us with something we can calculate. So 7.6 divided by cos 23, and this should be out to one decimal place. I get 8.3. Okay, now because I'm going to use that answer in a downstream application, either save that on your calculator or write yourself out more decimal places in order to figure that out. Because the last thing we want is little a. And so to do little a, I'm going to use Pythagorean theorem. Okay, so a squared plus b squared equals c squared. I'm looking for little a, so I'm going to subtract b squared from both sides. So I get a squared is c squared minus b squared, which is, so use the bigger number. Sometimes it'll make a difference, sometimes it won't. And that's minus 7.6 squared. Apologies for running out of room here, but when we do that calculation, what do we get? I get about 10.407 and so on. And so I'm going to square root both sides. And that gives me a of 3.2.